Hi everyone, this is Vijay Kumari working as Associate Professor in the Department of CSC, BVC Institute of Technology and Science. Through this video, I would like to explain few basic concepts related to algorithms. In this video, we will see what is an algorithm and what are its characteristics, what are the different types of design techniques available to develop an algorithm, and how the performance of an algorithm is analyzed in terms of space complexity and time complexity. We will see through an example in this video. First of all, what is meant by an algorithm? Algorithm is a method that can be used by a computer for the solution of a problem. In computer science, we need to develop solutions for complex problems. So in the initial stage, we have to develop an algorithm, and depending on its performance, we can able to convert that algorithm into a program. And algorithm should have finite set of instructions, and if we follow that instructions, it accomplishes a particular task. To develop an algorithm, 5 factors are important. Those are input, output, definiteness, finiteness, and effectiveness. Input specifies how many input values we have to supply for our algorithm. In algorithm designing, 0 or more number of parameters can be supplied as input for it. And output. So without taking any input also, our algorithm has to produce one value. At least one output has to be produced from the algorithm. Definiteness specifies how to write the steps in the algorithm. The steps in the algorithm should be clear and unambiguous. Means the steps should have unique meaning that can be easily understandable to the system. And finiteness, the steps what we are developing in the algorithm should have finite in number, means after certain number of executions, the algorithm has to be terminated. Effectiveness specifies how easily the steps in the algorithm are converted into a program and how the logic can be easily understandable to the other persons. So different types of design techniques are available to develop an algorithm. Those are divide and conquer, greedy method, dynamic programming, backtracking, branch and bound. So different types of techniques we have. By using any one of these techniques, we can able to develop an algorithm. But it is the factor which decides the performance of your algorithm is space complexity and time complexity. Space complexity is nothing but amount of memory that is taken by our algorithm to run to complete. Means when your algorithm is converted into a program and it is executed on a system, how much memory is taken by your algorithm to produce the output is considered as space complexity. And when your algorithm is converted into a program and it is executed on a system, how much time is taken by the system to produce the output is considered as time complexity. Depending on space complexity and time complexity only, your algorithm can be selected for converting it into a program. Let us see how to calculate the space complexity for an algorithm. Space complexity of an algorithm is defined in terms of two parameters. One is fixed part in the algorithm and another one is instance characteristics in the algorithm, otherwise variable part. So you can see here S of P is equal to C plus instance characteristics. C specifies fixed part of the algorithm and instance characteristics specifies the variable part. Means to calculate the space complexity, first of all in the given algorithm we have to identify the variables which needs fixed memory locations. And then we need to identify variables in the algorithm whose memory locations are dependent factors on its input, otherwise on its instance characteristics. So in order to understand these two parameters, I will explain these two parameters in terms of one sample algorithm. So this algorithm is used to add all the elements available in a one-dimensional array. In order to add those values, I have taken a variable s which is initialized to 0. So depending on the number of variables, I have to add variables one by one to s, and finally the sum is returned by this algorithm. So in this one, totally we have 4 variables. S is a variable, I is a variable, n is a variable, and we also have one-dimensional array. So to calculate its space complexity, first we need to analyze what are the variables which comes under fixed part. See here, s is equal to 0. One initial value is supplied to s, means in order to store that one, s requires one fixed location. And similarly, I also need one fixed location so that its value can be varied from 1 to n. To store the input value n, we need a fixed location. So the variables s, I and n comes under fixed part. Now one more variable is there, one-dimensional array A, and we cannot able to determine the number of locations required for A in the initial stage. The number of locations required for A is a dependent factor on the value of n. So how many number of values or how many number of memory locations required for the one-dimensional array are decided by the value of n. When we supply n value as 5, the one-dimensional array A contains 5 locations. So depending on its data type, continuous locations has to be allocated by the system. If we give some other value for n, now depending on the value of n, number of locations required for A is updated. So the value, the elements we are storing in the one-dimensional array, the value is a dependent factor on the value of n. So A is a one-dimensional array which needs n locations to store all its n elements. So among all these 4 variables, s, I, n, these 3 variables comes under fixed part, and one-dimensional array A comes under variable part. So one-dimensional array A needs n locations, and s, I and n, these 3 needs 3 fixed locations. So the total space complexity for this algorithm is n plus 3. Now let us see how to calculate time complexity of the algorithm. I am continuing with the same algorithm to calculate its time complexity. Initially, time complexity is defined in terms of compile time and runtime. So we need to measure how much time is taken by the system to compile your program as well as to run your program to produce the output. But later stages, compile time is not taken into the calculation of time complexity, since once you are compiling your program, so many number of times you can execute your program without any recompilation. So compile time is negligible, and the time complexity of your algorithm is measured in terms of its runtime only. So to measure the runtime of an algorithm, we are using 2 types of methods. One is known as step count method, another one is known as frequency count method. Under step count method, whatever the algorithm we are having, in that algorithm, first we have to identify the program steps. Means any statement or any step in your algorithm, whether it is having some execution time, will be considered as a program step. So after finding the program step, we need to identify the total number of executions of the program step. For this reason, in step count method, we are using one global variable known as count, which is initialized to 0. So for the same algorithm, when we modify that in terms of introduction of program steps, we are having the following process. So here, see the same example, s is equal to 0 and one for loop we have and one return statement we have. Among these steps, we have to identify program steps, means the statement which has some execution time. So s is equal to 0, it is an executable statement. So I updated the count variable by 1, and for I is equal to 1, this statement is also getting executed. So I updated count value by 1 after for loop. S is equal to s plus a of I. This is also an executable statement. So again I updated count value by 1 after s is equal to s plus a of I. And after closing of the for loop, I incremented count value by 1 in order to count the failure condition of the for loop. And return statement is an executable statement, but the count value should not be updated after return statement. Since after return statement nothing is executed by the system, so count statement is mentioned prior to the return statement. Now we need to identify how many number of times the count statements are executed total. So first statement s is equal to 0 is an executable one, and the count statement after s is equal to 0 is executed for only one time, and our for loop is executed for n times. Since the value of I is varying from 1 to n, for loop is getting executed for n times, and depending on the value of I, s is equal to s plus a of I, it is also executed for n times, and the failure condition of for loop is executed for one time, and return statement is also executed by one time. So if we add all these values, you will get the runtime of this algorithm. So I have to add 1 n 1 as well as 1, so that the total time complexity of this algorithm is 2n plus 3. Now coming to the second method, frequency count. In the step count method, actually we are introducing a count variable and we are calculating the total number of executions of the count variable. But in frequency count, we need to identify the total number of executions of the each and every statement without introducing any count variable. On the original algorithm itself, we need to apply the frequency count so that we have to finalize its time complexity. So we'll see how to calculate the time complexity in terms of frequency count. In this diagram you can see you have your algorithm, and after your algorithm the second column specifies what are the executable statements we have in the algorithm. So algorithm header is not at all an executable one. Opening brace and closing brace, these two are also not an executable one. The remaining statements are executable statements. So all executable statements are indicated by 1 and non-executable statements are indicated by 0. And after that we need to identify the frequency of every executable statement. Otherwise, how many number of times totally the corresponding statement is getting executed, we need to identify. So s is equal to 0 is the first executable statement in the algorithm that is executed for only one time throughout our program execution. So its frequency is 1. And for I is equal to 1 to n, this is also an executable statement, but the total number of executions of this statement is n plus 1. N times the condition becomes true and one time the condition is false, so that we can terminate from the procedure or from the for loop. So the total number of executions are n plus 1, and s is equal to s plus a of I. This is an executable statement and the total number of executions of this statement is n. Since depending on the value of I only, the corresponding calculation is taken. That means I values varying from 1 to n. So s is equal to s plus a of I is executing for n times, and return statement is executing for only one time. So steps for execution as well as frequency. We identified the executable statements as well as its total frequency. If we multiply second column with the third column, we will get the total steps, or what are the total number of executions of each and every step in our algorithm. If we add the elements in the last column, you will get the time complexity, which is nothing but 2n plus 3 for this given algorithm. So these are the methods available to calculate time complexity of the given algorithm. Hope you understand how to calculate the performance of an algorithm. Thank you.